Good afternoon, everyone. I'm John Rix Brasi, and welcome to the Geology for Civil Engineers. We have 6 topics to discuss. First, geomaterials resources. Second, space resources. Third, environmental protection. Fourth, ecosystem and biodiversity. Fifth, natural hazard. And the last one is climate change. Now, geomaterials resources. Geomaterials are products extracted from the geosphere that have undergone some degree of treatment used as construction materials. So, ang geomaterials ay likas na yaman na makukuha natin sa lupa. Kagaya na lang ng gravel and sand, clay, quartz, siliceous rock, limestone and marl, gypsum, hard rock, and scoria, and ornamental rock. So, ano siya ng mga mga materials mo niya itong makuha pag mag-excavate ta sa geosphere, which is anong maghukay ta sa atong lupa mo na ito makuha na materials na magamit na to sa atong construction site para makabuild ta og mga building, mga balay, or mga dalan. Mo na ang mga ginagamit. Next is the the types of materials excavate from the surface at work site, not including demolition materials, can be classified into 6 following categories. So, 6 following categories. Type 1, available materials that can be used with or without washing in the skirting geomaterials industry. Alluvium and hard rock debris for aggregates, blocks for walls and erosion protection, pure gypsum for the manufacture of plaster, marl, and limestone. So sa type 1, we have 4 cases. So case A, sub-horizontal layer. Sub-horizontal layer type of geologic materials extracted from the work site and possibilities further to use. Next is case B, oblique layer. Oblique layer principle of shearting materials as they come out of the tunnel under construction. Take layer parallel to the axis of the tunnel ideal condition. Next is case B, case C, subvertical layer. Subvertical layer possibility for shorting according to geologic and structure. Vertical profile along the tunnel axis. Very upright layer, good condition for shorting if the layer are thick enough. And the last one, case D, folded layer. Folded layer not favorable for shorting. So muna siya. Next is type makita. Type 2. Materials that can be used without treatment for earthworks, for transport infrastructure, or for landscaping. Unconsolidated sediment and rock debris with a low clay and water content. So there is a type 2, sustainable materials for use as construction project like road or landscaping without requires additional treatment. These materials typically contain the loss of sediment and rock debris with a low clay and water content, making them easy to work and suitable for various earthworks application. Ano siya ang type 2. Next, type 3. Materials that can be used at other work site with on-site treatment. Fill materials with a high water content can be treated with a lime or cement prior to compaction. So there is a type 3. This type indicates that materials with a high water content can be used at other site after treatment with the lime or cement to improve their compaction and sustainability for construction. Mao na siya ang type 3. Next is type 4. Materials with a high water content that required stabilization if a factory to be transformed into artificial aggregates, minerals, slurries. So the minerals slurries which have high water content need to be stabilized and a factor of turns them into artificial aggregates for construction purpose. Masya ang type 4. Now let's proceed to type 5. Materials can be materials that cause pollution for geologic reasons. Primarily evaporates gypsum and hydrate rocks and contain chlorides and rock rich the sulfates depending on the concentration of solvable materials. It can cause it can be used as the central body of embankment if it is confined by impermeable layer. If the content of soluble materials is too high, it should be disposed in a landfill. So this type of highlight that certain geological materials like evaporate and sulfide-rich rock can be cause pollution depending on their suitable materials. Concentrate suitable material concentration. They can be used in embankment if confined by impermeable layer. However, it has suitable materials that contain too high. They should be disposed of a landfill to prevent environmental hazard or harm. Next is the last one is materials that can pollute the environment for anthropogenic reasons. If contaminants are minerals, they can be managed at type 5. If the sustainable are organic, the materials should be incinerated before use. So this statement indicates the certain materials can be pollute the environment due to human activities. If the contaminant are if the contaminant are minerals like heavy metals, they can manage accordingly. However, if the substance are organic, the material should be increased before use to mitigate environment risk. So muna siya ang 6 type. Use of materials from the urban worksite to theory to practice in urban factory for making worksite slurries in town Tokyo truck. Dump slurries into the base where they are homogenized. So in the downtown Tokyo, the urban factory processed the materials from the urban worksite into the slurries. These slurries are mixed with emulsifier and cement to form the lightweight materials used in making artificial aggregates to, to fill urban entrenched uh, as a light fill of road in this layer. So this management policy, which seem laudable, at first glance requires deeper examination. The large quantities of cement required for treatment create a problem in terms of energy and global ecological balance. This management policy of causing cement of treatment and might seem beneficial initially. It purpose environmental concern due to the significant energy can consumption and carbon dioxide emission associated with the cement production. The overall environmental impact need careful consideration. Next is space resources. Space should be considered the resource even though it is used only for uh, uh, present scientific research at the present. So space should be viewed the valuable resource even though it is currently utilized mainly for scientific research. The highlight that scientific reconnaissance mission primarily focus on studying the geology of uh, planets and satellites in our solar system through high altitude and surface photograph. Next is the first astronaut to set foot on the moon also conducted the geologic observation. Astronaut on the moon conducted geological observation followed by robotic missions for space explorations. So next is reconnaissance mission to Mars will hopefully make it possible to add biological samples to this minerals analysis. So future mission to Mars aim to analyze both mineral and potential biological samples while practice application of these discoveries remain certain space exploration is driven by scientific curiosity and passion. Next is, bali lang na to ang kuan kay para makita. Photo of a rocky outcrop taken by the Curiosity of rover in 2015 on the margin of Hidden Valley. The rock is finely stratified sandstone, which crossbedding typically of sedimentary detailed environment and dates for the time when the water flowed on Mars. Next na to. Alisan na to na yung camera. Nice. Environmental protection. We have just discussed several aspects of environmental, particularly natural resources. We shall now discuss several other of ecological challenges that involve geology and that society must be tried to resolve. So, environment. So, in addition to natural resources, we are another ecological challenges related to geology and society needs to address. Next is ecosystem and biodiversity. What does geology have to do with ecosystem and biodiversity issues that seem the first glance to be pure purely biological? In fact, that because geology is large responsible for soil formation and its hydrogeologic condition, it affect the living environments of animals and plants. Water it is in fact of the limiting conditions of ecosystems. Um, it's emphasized that geology plays a significant role in soil formation and hydrogeological condition, impacting the living environment of animals and plants. Water availability influence geologic condition is crucial for ecosystem, which variation of affecting biodiversity, nationality, paleontology, underscore of the geological influence on ecosystem. Naman to siya ang ecosystem and biodiversity. Next. So, ecosystem and biodiversity. The southeastern part of Florida is a well-documented example of effect of geological condition. on biodiversity. So a coastal aquatic environment, a map from the beginning of 20th century compared the situation at the end of the century B, show the effect of the man's activity. So humans activity like building agricultural channels and overusing coastal aquifer alter alter underground water flow in the Everglades and Miami Miami. This change is hydrogeology affect biodiversity along the coast, leading to the expansion of high salinity margin ecosystem near Myanmar shore. Next is boring installed at some distance from the shore, such as boring BMI. For example, C. Show the conditions were different in 90th century before before intense of human activity in the region. So in the past, os ostracods were found suggesting low salt levels. But in the 20th century, forami, foraminifera, foraminifera showed up, signaling more salt due to less fresh water reaching the sea, changing the ecosystem to saltier. Next is overexploitation. Overexploitation of the aquifer by instance of pumping during 20th century has not put end of the freshwater contribution. It has also caused the saline water boundaries to move inland. So the geology conduct where the different coastal ecosystem would not have undergone the observed modifications. Tama na siya ang ecosystem and biodiversity. Next is geological condition of ecosystem on the evaluation of species throughout Earth history. Balisa na to ni mabasa. Nice. So to. Throughout the Earth history, one understanding example is the mass extinction linked to the aggregation of continents of the time of Pangea. Type of Pangea. So, understanding the interaction between the subsurface and the surface phenomena is crucial for understanding the biosphere. Additionally, rapid geodynamic event like volcanic eruption, flood, and landslide also impact ecosystem. So next, natural hazard. Type of risk causing phenomena. Wait lang. Balihin na po na ito. Phenomena have been described. So, seismic hazard, volcanic hazard, water-related hazard, slope and stability hazard. So, these are the two types of activities that can reduce this risk. So, we have land development code. Land development code involve the mapping phenomena and hazard the areas of higher hazard, designated unsuitable of construction. Conflict may arise if a parcel was previously approved for construction but is now designated as a high hazard. Next is engineering safety and measure. Engineering safety and measure when the land develop codes, the insufficient engineering safety measure are used For slope stability, techniques with technique focus on reducing stability. Drainage mechanical stabilization or protecting in structures. Hydrogeological actions are often more effective than mechanical methods in stabilizing slope prone to slide. Technique vary depending on the subsurface condition, with which groundwater groundwater manipulation commonly used for stability. Large la- uh, Large landslide may require extensive drainage system like the galleries with brown holes. So, muna siya ang engineering safety and measure. So, dito na to sa climate change. Um, Climate change. The problem of climate change has become the major concern of society. Increased temperature have been observed planet-wide since the beginning of the industrial era. So, it's only that indicates that climate change marked by rising temperature since the industrial era is a significant concern. The acceleration of temperature increase it is recent indicates that even though temperature data and glaze retreat retreat such a cha- uh, such as in the Alps. So muna siya. Next is climate change. Climate change is a certainty, however, it is the object of lively con, controversy. Most scientists attribute the change of an anthropogenic increase of greenhouse gases. A small minority think natural factors are dominant. So while significant climate change we have occurred naturally in Earth history, the current rate of change strongly support the idea that human activities are the main cause of the climate change. Next is green, uh, greenhouse effect is composed of many factors to quantify the effect of various factors. Scientists use the ideas of radiative forcing of or the change of energy flux and the tropopause as compared to condition 1750. So positive forcing led to warning the most human activities contributing positively carbon dioxide and methane the major contribute while the aerosols have a complicated role. And that's all for climate change. And thank you.